This is lesson 73, radical equations, which are simply equations with, and we're going to look at only equations with square roots in them. So we'll start out with the simplest. We'll do like a square root of, say, 2x plus 1. So we've got a radical equal to a number. We'll put it 5. Well, we know that if we want to get rid of a radical, then, and I will go ahead and say, you want to make sure your radical is by itself. If anything's attached to the radical, we're actually looking at this as our term that we're trying to get by itself. So on this one, and we want to get rid of a square root, so we're going to actually square, and whatever we do to one side, we do to the other. And so we're going to square all of this. Squaring the square root will get rid of the radical, and I'll be left 2x plus 1. And then when I square this out, I get 25. Subtract your 1. You get 2x is equal to 24. And x is equal to 12. Now, you do want to be aware, and we've talked about this before when we had equations with variables in the denominator. There are sometimes extraneous solutions. Now, this time, you're interested in when you end up with a number under your radical that is not positive or 0. Because you know that when we have negative numbers here, we're going to have imaginary answers, and we're not involved with imaginary. So, looking at 12, we know 2 times 12 is 24, plus 1 is 25. So, it works fine in this particular case. So, it's not a bad idea to check your answers to make sure. Because especially in your multiple choice, you may think there's an answer that doesn't work. Okay, let's try another one very similar to that. Let's do 6 times the square root of negative 1 minus 50x is equal to 42. Okay, you could square both sides as it is. We don't want to have to square this 6, not over here, because we still have to get rid of it. So it's better to get your radical by itself. And again, by itself. And that's getting the whole radical, everything under it, this whole thing by itself. So the 6 is attached by multiplication. We'll divide, and we get the square root of negative 1 minus 50x is equal to 7. Square both sides. I like to use parentheses. I get negative 1 minus 50x is equal to 49. And when you get there, you've pretty much just got an easy equation, and you'll just have to be careful and make sure your answers do work in the original problem. So we'll add the 1. We get negative 50x is equal to 50, and then divide by negative 50, and we get x equals negative 1. And putting that back under here, we have negative 1 minus 50 times negative 1, which would be negative 1 plus 50, which would be 49, which does work. And that's 6 times the 7, which gives you the 42. But the main thing is that you want to make sure that this number doesn't cause the original radicand, the number under here, to be negative. Okay, now let's do 1. So that's pretty much a radical equal to just a number, or if there's something attached. If you have something added to the radical, then you'll want to get rid of that first, and we may pull something in here in just a second. Now, a second type is when you have a radical equal to a radical. If I have the square root of 3 minus 3m equals the square root of negative 1 minus 5m. And I think you can see the easiest way, if you've got a radical, square both sides, radicals go away, and you have 3 minus 3m is equal to negative 1 minus 5m. I'm going to add the 1, and I get 4 minus 3m equals negative 5m. I'm going to move the 3m. I get 4 equals negative 2m. m is equal to negative 2. Now let's check and make sure, because especially with those negatives under there, we have to be careful. So we've got, oops, sorry, let me move that up just a little bit. So I've got 3 minus 3 times negative 2. So I've got 3 plus 6, that's fine. And then I've got negative 1 plus 10, which is fine. So everything works out well with that. Okay, let's do, and I think this is number 4. Let's do a problem where we have a radical equal to a variable. Let's take the square root of negative 14 plus 9n is equal to n. So, again, very similar to the first couple that we did. We're going to square both sides. We don't have anything attached to the radical to get rid of first. And so I have negative 14 plus 9n is equal to n squared. Well, automatically, this stands out to me that this is quadratic. It's easier to solve a quadratic if you put everything on the side where the squared term is positive. So I'm going to move the 14, and I'll move the 9n, and I get 0 is equal to n squared minus 9n plus 14. Okay, we see we got 0 equals, and we'll factor this into 7 and 2 because they multiply to 14, and they would have to be negative to add to negative 9. So this one will make n positive 2, and this will make n positive 7. Now, could we have two answers? Sure. Let's see if they both make for positive radicands. So negative 14 plus 18 will work, so the 2 works. And negative 14 plus 9 times 7, negative 14 plus 63, and that will work. The main thing is the radicand has to be positive. Number 5. Let's do a radical equal a binomial. Okay, and usually this is the one a lot of people miss. Hopefully this late in the year you will be aware of what's going to happen, but your radical is by itself, so we're going to square both sides. And I have to put that x plus 3 in parentheses because I'm squaring the left side and the right side. This gives me 4x plus 8. Now, remember what x plus 3 squared means. It means x plus 3 times x plus 3. So when I distribute that out, I'll get x squared plus 6x plus 9. It is quadratic. Let's get everything on that side. And I get 0 equals x squared plus 2x plus 1. And everything should factor very easily. And so we've got x plus 1, and we solve, and we get an answer of negative 1. Even though it was quadratic, our two answers are the same. And negative 1, 4 times negative 1 plus 8 is positive, so we have a correct answer. Okay, number 6. Let's do n is equal to the square root of 7n minus 40 under my radical, and then there's a plus 4 at the end. So anytime you have a radical with something attached to it, multiplied, divided underneath the whole radical. I don't think you see those that often, but especially added or subtracted at the front or back, you want to get your radical by itself first. So let's move the minus 4. And we get the square root of 7n minus 40. Now we can square both sides. Again, here is a binomial, n minus 4 squared. So I have n squared plus, minus 8n, because you got minus 4n plus minus 4n, and then plus 16 is equal to 7n minus 40. Okay, here's my positive n squared. So I'm going to move everything over here. I'm going to move the 7n, and I'm going to add the 40. So I have n squared minus 15n plus 56 equals 0. And I believe this is going to be 7 and 8. It's going to be minus 7 and minus 8. So n is 7 or n is 8. Now, will that work for the radical? 7 times 7 minus 40, yes. And 7 times 8 minus 40, yes. So we actually didn't have any extraneous. I don't know if they'll show up. Just be aware if you get two answers and you're looking at your multiple choice, there might be one that won't work, and that's why it doesn't show up.